Section 2.1 Power and radical functions. Let f be the power function f of x equals ax to the n, where n is a positive integer. In other words, the function that we're looking at is a monomial. If n is even, if the power is even and a is positive, so the coefficient is positive, then the function is going to look like x squared. So the domain is negative infinity to infinity. The range is 0 to infinity. We have x and y intercept at 0, and this function is continuous everywhere. The symmetry is the y-axis. We have a minimum point of 0, 0. This function is decreasing from negative infinity to 0, then increasing from 0 to infinity. The end behavior is this function is shooting up to infinity both on the left and the right-hand side. So as x approaches negative infinity and infinity, this function is shooting up to infinity. Now, when n is even and a is negative, we have like negative x squared, and everything is just upside down. So the ending behavior is now negative infinity, and the range is negative infinity to 0. Over here, we went 0 to infinity. When n is odd and a is positive, for example, we have x to the third, something like that, the domain and the range is negative infinity to infinity. X and y intercepts are at 0. It's continuous everywhere. It's symmetric over the origin, which means it's an odd function. There are no extrema, and this function increases the entire time. The ending behavior as we go to the left is negative infinity, as we go to the right is positive infinity. Now when n is odd and a is negative, so we have negative x to the third, for example, then the domain and range is negative infinity to infinity. X and y intercepts are 0, continuous everywhere, symmetric over the origin, meaning this is an odd function. There are no extrema, decreasing from negative infinity to infinity. So as we go left to right, this function decreases forever. The ending behavior is as x goes to negative infinity, the function is going to positive infinity. And as x goes to infinity, y is going to negative infinity. Graph and analyze each function. We have f of x equals 1/2 x to the fourth. So here is the graph. The domain is negative infinity to infinity. We have no denominators, no radicals. The range is 0 to infinity on this one. We have an x-intercept at 0, a y-intercept at 0, and the end behavior is the limit as x approaches both plus and minus infinity of the function is equal to positive infinity. Continuous everywhere, negative infinity to infinity, increasing from 0 to infinity. Now that's on the x values, so 0 to infinity, this function is increasing as we go left to right, and then negative infinity to 0, this function is decreasing as we go left to right. How about negative x to the seventh? That looks a lot like negative x to the third. So the domain, no problem with domains, no radicals, no denominators. The range is negative infinity to infinity. X and y intercepts both at 0. The ending behavior, the limit as x approaches negative infinity of f of x is equal to positive infinity. So as we go, x goes to the left, y is shooting up to positive infinity. And limit as x approaches infinity of f of x, as we go to the right, this function is going down. This function is continuous everywhere. This function is never increasing as we go left to right, and this function is decreasing from a negative infinity to infinity as we go left to right. 3x to the negative 2, that's the same as 3 over x squared. Notice this function cannot be negative, so none of the y's will be negative. The domain is negative infinity to 0, and then union with 0 to infinity. We have to skip over 0. 0 cannot be in the denominator. The range is 0 to infinity, but y can't be 0. X-intercept is none. Y-intercept, none. End behavior, limit as x approaches both plus and minus infinity of f of x is equal to 0. This function levels out to 0 on the left and the right-hand side. The continuity is the same as the domain. 0 to infinity, increasing from negative infinity to 0 and decreasing from 0 to infinity as we go left to right. Negative 3/4 x to the fifth, that's like having negative 3 over 4x to the fifth. Notice now the domain can't be 0. We do have a variable in the denominator. So negative infinity to 0, union with 0 to infinity. The range is negative infinity to 0, 0 to infinity. Notice that y cannot be 0. There's nothing we can plug into this to make y equal to 0. The x-intercept, again, is none for this one. The y-intercept is none, not possible. And the limit as x approaches plus or minus infinity of f of x is equal to 0. This function levels out to 0 to the left, levels out to 0 on the right. The continuity is the same as the domain, negative infinity to 0, 0 to infinity. This function increases from negative infinity to 0. So as we go left to right, this function is increasing the entire time, and then, or at least from negative infinity to 0, and decreasing, oh, actually it's increasing once we skip over 0, 0 to infinity, and this function never decreases. How about x to the 5 halves? We kind of have a radical here. This is the square root of x to the 5th. The domain is 0 to infinity. You can't plug a negative in here because you can't take the square root of a negative. The range is also 0 to infinity. X-intercept is 0, y-intercept is 0. The end behavior is limit as x approaches positive infinity of f of x is equal to infinity. We can't talk about as the limit as x approaches negative infinity because we can't use these negative x values. The continuity is from 0 to infinity. That's on the x values, increasing from 0 to infinity, and this function never decreases as we go left to right. Let f be the radical function f of x equals the nth root of x, where n is a positive integer. If n is even, it looks like the square root of x. And you can't have negative values, so you notice the domain is 0 to infinity. And when n is odd, you can take the third root of x. You can take the third root of negative values. For example, the third root of negative 8 is negative 2. So the domain and range is negative infinity to infinity. Graph and analyze each function. We have 5 times the square root of 2x to the third. Since we're taking an even root, we can't allow x to be negative. So the domain is 0 to infinity. The range is also 0 to infinity. The x-intercept is 0, the y-intercept is 0, and the end behavior is the limit as x approaches infinity of f of x is shooting up to infinity. So as x goes to infinity, y is shooting up to infinity. Continuity on its domain, it's continuous on its domain, increasing from 0 to infinity, and this function never decreases, so that would be none. Graph and analyze each function. Now we have the fifth root of 3x minus 4. We can take the fifth root of negative values, so the domain is negative infinity to infinity. This will go up and down forever, although rather slowly. So negative infinity to infinity. X-intercept, that's what makes y 0. So we would have 3x minus 4 needs to be 0. So 3x equals 4. So x, the x-intercept is 4/3. So this crosses the x-axis at 4/3. Now, to get a y-intercept, we have to plug 0 in for x. So we have 1/2 times the fifth root of, we plug 0 in for x, we get negative 4. So whatever the 1/2 times the fifth root of negative 4, and that's that value right here. So it's a little less than 1. The end behavior, we have the limit as x approaches infinity of f of x is positive infinity. So as we go to the right, this function is going up. And the limit as x approaches negative infinity of f of x is equal to negative infinity. So as we go to the left, this function is going down. The continuity is on its domain, negative infinity to infinity, increasing from negative infinity to infinity as we go left to right. And this function never decreases, so none. Solve radical equations. Let's get the radical by itself. So we'll add 3 to the other side. And we get square root of 28x plus 29. Now we can square both sides. So we get 4x squared plus 12x plus 9 is equal to 28x plus 29. Now let's minus 28x. Minus 28x. We got 4x squared minus 16x. And we'll minus 29 from both sides. Minus 29. So we get minus 20 equals 0. Let's factor out a 4. We get x squared minus 4x minus 5 equals 0. And then we have x minus 5 and x plus 1 equals 0. So x equals 5 or x equals negative 1. Now let's try these. We have 10, when we plug 5 in, is equal to the square root of 140 plus 29 minus 3. That's going to be square root of 169 minus 3. That's 13 minus 3. That's 10. So the 10 does equal 10. 5 works. How about on the other side? We have the other value. We have negative 2 is equal to the square root of negative 28 plus 29 minus 3. That's going to be the square root of 1 minus 3. 1 minus 3, negative 2. They both work. So x equals 5 or x equals negative 1. Let's solve this one. Let's minus 8 over. We got 4 is equal to the third root of x minus 2 squared. Let's take both sides to the third power. Third power. That's 64 is equal to x squared. Well, let's do this. We got 64 is equal to, we got x minus 2 squared. Let's square root both sides. We got plus or minus 8 is equal to x minus 2. So x equals 2 plus or minus 8. So x is equal to 10 or x is equal to negative 6. Now let's try these. Let's try the 10. We got third root of 10 minus 2 is 8. So 8 squared plus 8, which is the third root of 64 plus 8. That's going to be 4 plus 8. Yep, that's 12. And then let's try negative 6. So we have the third root of, let's plug negative 6 in. We get negative 8 squared plus 8. We have the third root of 64, and we're right back. We're in the same spot now, 4 plus 8, and that is also going to be 12. So they both work. X equals 10 or x equals negative 6. Solve radical equations. Let's solve this radical equation. I think we should start this one by squaring both sides. So let's square both sides. On the left side, we just get x plus 1. That's equal to, let's see, we have 1 plus 2 times the square root of 2x minus 12. And then we have plus 2x minus 12. So let's subtract 1 from both sides. And then we can minus 2x from both sides. That's minus x. And then I'll add 12 to this side. Add 12. I'm trying to get this radical by itself. And that's equal to 2 times the square root of 2x minus 12. Now when we square, we can square both sides now. So square both sides. Square this side. But we got to remember to square this 2 also. We get x squared minus 24x plus 144 is equal to 4 times 2x minus 12. So we have x squared minus 24x plus 144 is equal to 8x minus 48. So let's minus 8x. We get minus 32x, and then we'll add 48. That's going to be plus 192 is equal to 0. Then we can factor this. We have x minus 8 and x minus 24 is equal to 0. So x equals 8 or x equals 24. But when we square both sides, we can run into problems. So let's check the answers. We have square root of 8 plus 1 is equal to 1 plus the square root of 16 minus 12 when we plug in 8. That's 3 is equal to 1 plus square root of 4. That's 1 plus 2. That's 3. 3 equals 3. But look what happens when we check 24. We get square root of 25 is equal to 1 plus the square root of 48 minus 12. And that's going to be 5 is equal to 1 plus square root of 36, which is 1 plus 6, which is 7. 5 does not equal 7. So 24 is a bad answer. It's an extraneous answer. It's an extra answer.